Okay, so let's keep cooking. So last time we were talking about some other stuff, right? And then, so we need to get back to the homework for last class was to update our environment, correct?
Yep.
All right, so we started writing that. So that guy is up here. Then I said we're going to be talking about recursion today, right? Okay. So let's see. We have empty environment, extend env star, and then don't we have a update env that we started writing with some dots here, and those dots would have given us an error telling us where we needed to pick up. All right, so for update environment, we are looking for the closest version of a variable name and giving it a new value within our environment. So if we're dealing with the empty environment, we'll just return the environment. Appel mentioned last time, do we even need to do that? Well, we don't need to make the extra recursive calls. So when we get to the point, if we say, oh, we found it, we can just tack on the rest of the environment that we're dealing with, and that gives us our whole environment. But I guess there is a potential here, even though we historically haven't done error checking, where we've said, what if they pass in the empty environment, then we can just boil down to the environment. So this isn't necessarily wrong. It just might not get called very often. Okay, so if it's the empty environment, boil down to the empty environment. Otherwise, we must be dealing with an extend env, right? Where an extend env is going to be, if we look at what that guy looks like up here, extend env is going to be a list containing a variable name, a value. So the car of the list will be the variable name, the catter will be the value, and the env will be the rest of it, right? So we want to ask the question, is the car of that guy the dude I'm looking for, right? So in update env, we're going to say if I'm not dealing with the empty environment, it must be an extend env, which means there must be a car. So if eq car env is equal, so if we're dealing with something that's equal to the name we're searching for, if that's the case, then we're going to boil down to a list containing name, new value, and the rest of the environment, which is a CADDR of env. Found my variable, keep the name, change the value, here's everything else, new environment. Does that make sense? All right. Else, I'm not dealing with the variable name I'm looking for. So what am I going to do? I'm going to keep the first parts, right? And call update env on the environment part of this. So I'm going to build a list out of name, catter of env, and actually let me, well, this will actually look okay, and then calling update env on name, new value, CADDR of env. So if it's not the guy I'm currently looking for, let's just maintain our current thing. You could have replaced name. Actually, this is incorrect. CA, so car of env. So keep the variable name that's currently there, keep the value that's currently there, and then the potential updated environment will be whatever's returned by update env, passing it the name I'm looking for, the new value I want to replace it with, and the environment that you might find it in, CADDR. That makes sense? So that should be update env, and in this 1-2 punch logic, this first thing would never actually get called, right?
What is that that thing on your head?
It's a bunch of things.
I don't know. He has like a hamster on his head.
Oh.
Oh, it's kind of fresh.
All right, so we'll come in. We're going to go ahead and call this. So we're going to go down here to our, where's my, did I start writing this part of it in here? Set expression, right? This guy right here. So if we're dealing with a set expression, what does my set expression look like? Set expression has a name and a value, just a new name and a new value.
Mm-hmm.
Set expression has a symbol and an LC expression.
Yeah,
Okay. The value will be the apply expression of the LC expression, right? Okay. So we're going to call. Did I write getters for expression or set expressions? Like get var name and get var value?
I believe so.
I think you did.
You're gonna make me scroll. Set expressions, set expression get var name, set expression get var value. Okay. So if I'm dealing with a set expression, then what I'm going to do is I'm going to call update env, passing it set exp, and I might kick this down a line in a second, but we'll just start typing. Get var name, like that. That looks reasonable. That looks probably like what I would have written from expr.
Mm-hmm.
So that's the variable name. Then I'm going to call, and I'm going to actually go ahead and kick this down a line. Then I'm going to call apply expression on whatever's returned by set exp get var value. Actually, does get var value call apply expression? Probably not.
No.
Okay. So set expression get var value from expr with the, and I'm applying that expression whatever the current environment is, right?
Mm-hmm.
All right, so this is going to be my variable name. This is going to be my new variable value, and I'm doing all this in the context of the value, the environment I'm updating is the current environment. So that should be it for set expression. So then if we come down here, yep, so if we come down here, well, in block expression, we already have a block expression is a collection of expressions. So we're going to be calling apply expression on it.
But then if you don't have the set in the block expression, then how would you gonna pass a new environment?
Yeah, we want to do something basically the same thing we were doing with remember instead of block expression.
Because it's actually changed the environment.
So we can change the environment inside the block expression.
Oh, because we'll get a new, so just like what we did here, we're treating remember expressions as special cases.
Yeah.
Because potentially, remember expression gives us a new variable, a set expression gives us an updated environment, right?
Mm-hmm.
So if we're not dealing with a remember expression, really we can do an or set expression if either of those things are true.
Mm-hmm.
Go ahead.
I'm just wondering, wouldn't it have maybe been easier to combine the set expression into the remember expression depending on what apply environment finds?
Potentially. I mean, that's kind of goes hand in hand with your question from last time, is what's language design versus implementation. Yeah, I mean, we just decided to treat it as a whole separate kind of animal. Which, if you model after a language like C, it is a separate animal. C, you would say int a equals 5, and then if you wanted to update that, you would say a equals 5.
Right.
So it is a similar looking, but it is a different type of expression that omits the type.
I was always under the impression int a equals 5 is syntactic sugar for 2 lines, int a, and then a.
Probably is in most for most compilers. Okay, so if we're not dealing with a remember expression, so we have a cond up here. If it's null, we do nothing. If it's not a remember expression, then we do all this stuff. really what we're saying, if it's not a remember expression and it's not a set expression, both of those things need to be true. So if it's not a remember expression and it's not a set expression, if both of those things are true, then we just treat this guy as a plain Jane, nothing, blah, 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 right? Else, in this case, we're already presuming it's a remember expression. So at this point, it might not be a remember expression. Now it might also be a set expression. Correct? If I'm down here, I don't know what, before we were presuming it was going to be a remember expression. Now we don't know which of the two extra guys it is, right? So really this can be a env changing exp. That's the kind of expression it is, something that that will change the environment. Okay, so we'll go ahead and get our that expression. We get our new environment by calling apply expression on that guy, right? And then ultimately we can call apply expression on the rest of it with our new environment. That make sense? Let's see, where's this guy? Okay, so I think that finishes our let the parameters of that, and then here's our call to the function. Okay, so now we can come down here and test this guy. Is this allowed right now? So set expression A equal to this stuff, and then call app expression on add stuff, blah, blah, blah. Okay, I think that should give us real values. So there's our 530. So our environment can update. All right, so questions on that? Okay, so now we want to think about recursion. First, what is it? And then after you answer that the wrong way, what is it really? So tell me the wrong answer to what is recursion.
That's when a function calls itself.
Okay, when a function calls itself. Okay, when a function calls itself from within itself. But it's kind of implied, right? And that's not so much wrong as it's not really very helpful for us to start thinking about how might we implement that guy, right? You know, if it kind of is more informational, like, okay, can I solve this problem recursively? And typically we've used like factorial as the recursive. You know, it's mathy enough that can be in a computer science classroom, and it's also a recursively defined function. So, you know, 4 factorial is 4 times 3 factorial, which is 3 times 2 factorial, which is 2 times 1 factorial, which is 1. So we end our recursion at the 1, and then it unrolls. So when I say that, what is it really? If we draw our picture there, if we say 4 factorial, this is actually 4 times 3 factorial, where 3 factorial is actually equal to 3 times 2 factorial, where 2 factorial is actually equal to 2 times 1 factorial, where 1 factorial is actually equal to 1. Okay, so as soon as I hit this 1, then that final call. So what happens between when I call 4 factorial, what am I doing? I'm saying, okay, I'm going to return. So we'll actually put that in there. We'll say return 4 times whatever the factorial of 3 is. That's a new function call, correct?
Mm-hmm.
It's the same function. It's when a function calls itself from within itself, but this means that this current version of factorial, the original call, gets paused, gets put on hold, because it can't answer its question until we have the answer from this guy. So now we have a separate call to factorial, and what does this guy do? It returns 3 times 2 factorial. Now, this guy also can't provide his answer, because his answer is reliant on the answer of 2 factorial. So he gets paused. So now I have two versions of factorial that are mid-execution that can't continue until somebody else finally starts giving some answers. All right, so then we're going to return, this is our third call, 2 times. Oh, did I actually put that in there? I thought that was a piece of like dust or something on my screen. Is that what you're laughing about? Or you're just laughing at other random stuff? All right, so this guy's on hold, this guy's on hold. This last one, we're in mid-execution, 2 times 1 factorial. Oh, here we go again. We can't answer this one. We can't return the answer here until we have the answer of this guy. A lot of books will call recursion, we'll call these promises. We have a promise that this guy will eventually boil down to something. We have a promise that this guy will eventually boil down to something. We have a promise that this guy will eventually boil down to something. We're really banking on that. Otherwise, we're going to get caught, right? We're going to get stuck in our recursive loop, something like that. That's probably more meaningful in a scheme class than, because we are using it for loops. But we'll get caught in there, and that's bad. All right. Finally, we get down to the final call where it says, oh, if the value you're trying to take the recursion of, or take the factorial of, is a 1, your answer is 1. We're done. This guy has finally given his answer, which allows this guy to finally give his answer, which allows this guy to finish. So this guy finally pops out a 2, which then allows this guy to give his answer, which finally pops out a 6, which allows this guy to finally give his answer, which finally pops out a 24. Make sense? Okay, so that's recursion in action. How do we implement this? Okay, so we know what recursion is at the high level. Now we've seen how does recursion work mechanically. Now we have to ask the question, how do we emulate that in our language? What special things are we doing here? We already have regular functions with lambdas, right? Go ahead.
We're making new function calls within itself.
Okay. Yep. So we're just
Passing new
repeating.
parameters to the function.
Okay. So a function has now the ability to call another function from within it. Now, do we already have that ability? Can we have an app expression inside of a lambda expression?
Sure.
Yeah. So we could already in our language call functions inside of each other, right? I mean, if I come in here and we gut this, here we'll just remember a couple of, here's our add stuff. We'll just get rid of our set expression. So can I say app expression the first thing is a lambda of our expression, and then we're passing it 2 parameters, but can we actually pass it the result of a app expression? Let me kick this down the line. Passing it my var expression add stuff. A and B, and then another app expression, passing it my var expression, add stuff, and a list containing a lit expression 1 and a lit expression 2. So this guy here, we're calling add stuff. Well, we're applying add stuff to the result. This should be in a list, right? App expressions take a list of things. So it's a list containing the first element being this app expression and the second element being that app expression. These are the two parameters we're passing into this first app expression. So this app expression right here has a first parameter, this, a second, and then a list containing the two parameters that go into that guy, whatever var A and B are. So that's going to give us A and B added together, right? What I've highlighted there. And that's going to give me a number, a single number. This guy is going to give me a single number of those guys added together. And those are going to then become our inputs to this app expression, which is the same add thing. So it's going to add the result of this to the result of that, giving us a result, a final answer. Make sense? So is this a function call inside of a function call? Sure. I don't even know what this guy's supposed to give us. 15 sounds right enough. 7 plus 3 is 12. 1 and 2 is 3. Yep, so 15 is right answer. 12 plus 3 is 15. Yep. 7 plus 5 is 12. Well, I wrote 5. Whatever I said, it's insignificant. That's what I wrote. 7 plus 5 is 12. A and B are 7 and 5. 2 and 1 are the other ones. 2 plus 1 is 3. That's where the 3 came from. It's possible I misspoke. But this is the right math, right? All right, so we already have the ability to have calls to functions inside of functions. That's nothing new. Can we potentially call the same function within a function? Could I write add nums in terms of calling himself? What would that take? So right now I have, sorry, not add nums, add stuff. Right now I have a function called add stuff. That's a lambda that takes 2 parameters. Could I write this guy in terms of calling add stuff in here? Could I put a app expression in here like this? Can I say app exp and then pass it a var exp add stuff along with the parameters for that, which would be maybe whatever's returned by this guy. Let's keep up here. Here we go. Let me kick this down a line so I can keep myself sane. Let me kick it down at a different place. There we go. Well, it's still not great, but whatever. All right, so add stuff is going to be a lambda. Takes in 2 parameters. And inside there, he's going to call himself, passing himself 2 parameters. So maybe we have a list of yeah, we already have X and Y there. Hardest part here is making sure we use our syntax correctly. All right, so we have a list of the first guy, and then we can say lit exp4, let's say. Okay, so that is a legal app expression calling add stuff with the result of X and Y and 4, right? Just this lit variable 4. And this guy is going to be used in the context of whoever calls add stuff, passing it 2 values for X and Y. So for instance, down here, we're calling add stuff, passing it an A and B. A and B will come in for X and Y. What will the result of this guy be? It'll be applying add stuff, the same function that we're in the middle of writing, to the parameters, first parameter being the addition of X and Y. and the second parameter being a 4. And x and y should be a 12. Second parameter should be a 4, which is a 16. And this guy is now calling himself, in theory. That would be an example of recursion, right? If this functioned. All right, so that's what add stuff is. We can come down here. Let's just simplify this guy down here in the bottom and call a there's my var expression. So I don't need that. There's A and B there. All right, so I've defined my add stuff here, and then I'm calling my add stuff, passing it a list of a list for some reason, passing it those two parameters, A and B, whatever they are, and they're 7 and 5. So 7 and 5 come into add stuff. Add stuff takes in 7 and 5 for x and y. What does it do? It applies add stuff to x and y added together, which will be 12, and a lit expression of 4, which should be a 16. We appear to be stuck.
I don't have a way to stop right now.
Because what is... We got to convince it to stop. Give me a moment. You think so? I thought that turns gray when it doesn't.
No, it said user break and it has an input now.
Oh, okay. Oh, thank you. I still like pushing the button extra times. It's satisfying. All right, so we have this guy here, which I think is written correctly in our language, right? It's not functioning the way we intended it to function, but I think it's written correctly. It's a function that it's a function that does call itself. But what does it keep doing? It keeps calling itself over and over and over and over again. So really, we need to have the ability in here to have it call itself conditionally, right? So if we wanted to do this as factorial, because that's kind of the direction we're going here, right? We want to be able to say, let's just call this guy factorial. And factorial is going to say take in a single parameter. Let me just get rid of all that stuff. So it's going to take in a single parameter, and what's it going to do with that parameter? Well, it's going to ask a question. It's going to say if, was it if expression? Well,
I think we have a
question. We have a question expression like this, and a question expression, what? We operate off of 0 and 1. So 0 being false and 1 being true. Is that a correct statement? So can't we say question expression var exp x? If that comes down to a 1, that's true. Correct statement, right? So then I can boil down from that to a lit expression of, well, or a var expression of 1, but here, lit expression 1. That is, so if x is equal to 1, that's how we deal with our booleans, isn't it? If x is equal to 1, we'll get into the true expression part of this where we'll just boil down to 1. Otherwise, we're boiling down to the result of math expression, and math expressions take a operator. Do I call it a math op, or do I just give it the multiplication?
It's just a symbol.
Just that. So multiplication of var expression x, and these guys have to have that guy on it, right? So var expression x. So I take in my, I'm multiplying that guy by whatever's returned by app expression, passing it factorial, passing it var expression factorial, right? And then passing it my one parameter, which would be a math exp minus var exp, var exp x and lytics exp1. I think that's it. So factorial takes in a single parameter. We ask a question, is x equal to 1? We kind of take advantage of how we're representing Booleans. If x is equal to 1, we just boil down to 1. So I can either write that or I can say var expression x. Either one's going to come down to 1 if I'm right here. Otherwise, I'm going to return x times whatever's returned by my app expression factorial. So this is the current value of x times whatever's returned by factorial of x minus 1. Until we finally hit a 1, and that's our end case right there with a 1. Correct? So I think that is written factorial accurately. Does that look good to everybody in our language?
I'm having difficulty reading that.
I think it looks right.
In question EXP, we list our true and then our false, right?
True right there.
False right there.
False right there.
And then
End of question.
if we're using the C method, where anything that isn't C, or anything that isn't 0 is true, then aren't we?
Yeah, that this potentially becomes a problem. Do we?
Right, we
do,
might have this flipped, I think.
oh, for how we wrote question?
Right.
Well, let's take a peek. Oh, we do have something called a bool expression. Oh no, we don't. Oh yeah, no, we don't. That's just a variable name. So if it's equal to 0,
Equal to 0, then we call our false. Otherwise, we call our true.
yeah. So that means that anything that's non-zero is going to hit our true
Right.
in the way we're doing this. Okay, so we got the plate. We got the
non-zero. We immediately hit 1.
Okay, well we can fix this. So we have to hack this within our language, right? So our language currently has a constraint. So really what we need to do down here in our block expression is we need to flip our true and our false down here, where we're going to boil down to a lit expression in our false. So really what we want to do is we want to say math exp minus this guy lit exp 1. If that's a 0, then let's see, how will that work? If that's a 0, we're treating that as a false. Right? So if that boils down to 0, that's when we want to have the 1. Otherwise, we'll do the true, which is that guy.
Of course, if we're just swapping them, then we didn't even need to do that. We could have just left the.
Well, yeah, we could have left it as a 1.
Wait. Yeah, because 0.
That would just be the false.
Still
Yeah.
1.
Actually, with that in mind, if it was a 1, 1 would be false. It would have done the opposite.
Right. And
So just swapping them.
Axiomatically, 0 factorial is 1.
Yeah. But I think this is more accurate. This is more accurate because this lets us say, does it boil down to 0? If this boils down to 0, then do the false stuff. That make sense? Otherwise, if it's not 0, then we're going to do the true stuff. I think this, and we had to do it like this or something along these lines because we had to hack how our Booleans work because we didn't write Booleans into our language at this point. We don't have the ability of doing logical Boolean operators. We don't have the equivalence operator. Is it equal to 1? We can't ask that question in our language. Might be handy soon to add that to our language, but we don't have that yet. All right. Maybe we'll even, given time, maybe we'll even add that for next class before we do the implementation for the recursion. But a hack inside of our current thing would allow us to say, does this let us say, if the current value of x is actually 1? It does. In a roundabout way, this says if x is 1, that means that x minus 1 is a 0. And if this guy boils down to a 0 in a question expression, we do the false. Right? Otherwise, we do what's in the true, where we'll multiply the current value of x times whatever's returned by factorial of x minus 1. All right, so that's factorial written in our somewhat ghetto language, let's say. And then down here, we'll go ahead and call factorial, passing it a, well, we could pass it our var expression of b, and just so we have values that we're used to dealing with, we'll put a 4 there. So this guy should return 24 as our answer. That makes sense? And we do have a stopping point now. I don't have my set expression in there anymore, do I? Okay, so this is breaking, I think, for the right reason. Just confirm that real quick. Yeah, so inside of my block expression, if we're not looking at a remember or a set expression, if it's neither of those, then we'll call apply expression on the rest. So actually in our current code, we're not using a, so I can actually take that out. That's not going to change our error here. It's fine. We'll just simplify what we have. So this guy should work just fine. And for just a moment, I'm going to take out this line. All right. So we see we are able to store 2 variables, right? So now if I put that line back in, it's our call to app expression where we pass it var expression factorial, and we can pretty confidently say we're going to retrieve that lambda from our environment, right? Retrieving a lambda from the environment is like no big deal. We're just not applying it. We just stored it in there. It's ready to go. Okay, so we'll get that out of our environment. So this first part of that app expression should be no problem. The second part, I'm passing it a var expression for b. That should also be not a problem. I should be able to get the value of B all day long. It'll give me my 4 and move on with life. So this is a 4. This is a lambda. We're passing a 4 in for this guy. So now we start having to figure out what is happening here. What's the logic of this? So if I take in, this guy boils down to a 4, correct? And we can prove that to ourselves. If I happen to, we're just going to piece this apart. If I happen to remove that, I'm going to boil down to a lit expression of 10 for literally no good reason, we'll say. So factorial is going to take in a value, and if that value minus 1 is a 0, it's going to give me a 10. Otherwise, it's going to give me a 1. So right now, I'm passing in a 4. Is 4 a 0? Okay, so since it's something other than 0, I'm going to get the 10 out of it, right? There's my 10. If it happened to be a 0, which means I would have passed in a 1 here for B, 1 minus 1 would be a 0, then I'll get my, we'll make that a 3, just so it's different values. Now I'll get a 3 out of this guy. All right, so my hacked if statement is doing what it's supposed to do. It's bouncing back between a, whether it's a 0 or a non-0 for performing the right stuff. Okay, so let me roll back here. All right, so we know that the issue is somewhere in there. So we have to think about, how do we actually piece apart this? Well, what am I doing? I'm doing a math expression. I'm multiplying some stuff. What am I multiplying? I'm multiplying the current value of my var expression. Is that guy likely to work fine? Sure. Current value of x, in this case it's going to be b, which is a 4. I undid this, so this is a 4. Then I'm calling my app expression. What does this guy boil down to? He boils down to a lambda, right? Are we pretty confident we're going to find that in our environment? We didn't delete it from our environment when we looked it up previously, right? So we're going to find that. This is no different than me saying something like who? A number.
Hang on. So then you take an app expression, take a var expression, and a list. While if math expression only return a number, which means
so this needs to be a list. Like that?
I don't know, but
yeah, because app expression needs a list of parameters. And the list of parameters I'm going to give this guy is no, that's not a list. Yes, it is. My var expression factorial takes in a single parameter. What parameter am I going to give it? I'm going to give it the one value that is the result of my math expression of taking x minus 1 as a list. Like that. And then that's the end of that math expression. Because remember, our app expressions, we now support having more than one parameter passed in. So we take in a list of parameters. There's our 24. Why does this work? Did we have to do anything special to implement recursion?
We said that in break case.
Well, that's how we stop recursion. Okay. But did we actually implement recursion here? This kind of goes back to a question we've been asking in the last 2 or 3 classes.
because we keep doing the var expression recursively.
Who knows how to do recursion here in what we're implementing?
Scheme.
Scheme knows how to do recursion. So if Scheme knows how to do recursion and we're using Scheme for implementation, are we kind of cheating off of Scheme for recursion? And we are. Now, is that a problem? Well, as long as we're relying on Scheme as our underlying language, it's not necessarily a problem. But what if we had to implement recursion ourselves? What if just for some reason we took off the table that we were allowed to use scheme as our, what if we said you're not allowed to use scheme's recursion? We would probably have to give ourselves, we would have to say you're not allowed to use scheme's recursion inside of call a lambda expression, because even that's going to have a shortcut.
I don't see how we're really leveraging off of scheme's recursion any more than we do with anything else.
Correct. We do it for everything else, but in this case it matters.
Else, we're
Right. Correct. Everything else is the
resolve
logic related to our language.
Right.
In this case, it's not stealing a feature. So now we go back and well, why didn't we just use set bang for the environment? Why did we create our own structure for the environment rather than just using set bang from scheme? And schemes hold defined structure for defining variable names. You know, we didn't because we wanted it to be our language. So at this point, we almost need to put special. If we want to think about how recursion is implemented, we have to put special constraints on us, and basically just say, you know what, this isn't allowed. We're not allowed to make a call to yourself within a lambda directly. So we kind of need our own little pod for our own little recursion to exist in. How can we accomplish that? How does recursion exist in scheme but outside of its core implementation?
Does it make a new environment?
Okay, and what do we get? How do we get a new environment that supports recursion? How do we give ourselves a local environment in scheme? With let. Okay, and how do we give ourselves a local environment that supports recursion? The let rec. So maybe we need to look at implementing a let rec in our language, which will then give us a nice little pod for recursion to exist within, right? Even with that, we're going to have to modify our rules to say we cannot call a function recursively using scheme's underlying thing. We have to treat it as our own version of recursion and handle it, and we'll have to think about how do we accomplish that, maybe with like a stack. Okay, typically the saying with languages is that anything you can do recursively, you can do it with a you can do iteratively with a stack. Okay, so for Monday, because we're seeing some difficulties in asking our Boolean, our remember expressions are a little limiting right now. Let's give ourselves the logical Boolean operators. So we want to have equal, not equal, less than, greater than, less than or equal to, greater than or equal to, and I think not equal to will. That'll give us lots of flexibility. I already have not equal to. Do it twice. All right. All right.
2 kinds of not equal.
That will allow us to ask numeric questions for equivalence, right? So add that to your language in whatever way makes sense for you. You can imagine how you want those called. I'm probably going to, actually, I don't even know what I'm going to call them yet. We'll find out on Monday. But, you know, at some point here, I want you to start differentiating your language into something that you're inventing and not just mimicking off what we have here, although I do understand that sometimes you want to have a working starting point, and mimicking off of the language we have in class gives you your best chance of success for the homework. All right, but does everybody understand what we're doing for the homework? Giving ourselves to the ability to ask better questions, question expressions. All right, I will see everybody on Monday. I believe some students are getting together for a mini hackathon-y thing tomorrow. Check Slack. Noah Kurtz is putting up the information for that. I encourage you to show up and hang out and work on some stuff. I will be in and out at various times, but I really encourage you to get together and work on projects outside of what you're just doing on schoolwork to get some experience. All right, I will see everybody on Monday.